Add the numericals. First point, you have to remember the 5 processes, 5 thermodynamic processes. What are those 5 thermodynamic processes? First point, isochoric process. Okay, what is a condition for isochoric process? Which property remains constant? And dear students, there are 3 major properties you need to remember. Okay, one is pressure, temperature, and volume. You remember these major properties. So if the pressure is constant in the process, that you call it as isochoric process. Pressure is equal to constant. Okay, this is a hint. And for this process, you have to remember expression for work done. Okay, do not remember the expression for heat. First, you remember only expression for work. So expression for work.
Sir, you said that isobaric is pressure constant, sir.
Okay, here it is isochoric I have taken, no? Right, correct, very good. So here it is, I will to change to volume, very good. So volume is equal to constant. So volume is equal to constant. So we have to write or remember the expression for work done. Okay, work done expression for all these 5 processes. Before remembering the expression for work done, my dear students, just remember this expression. Work done is equal to integral of PdV. Okay, why I'm telling this equation is, in some of the numericals, you will not mention what type of process. In general, it may be some thermodynamic process. It may be isochoric, it may be isobaric, constant temperature, isothermal, or adiabatic, whatever may be. We will not mention particularly. So we cannot choose any 5 equations until unless he mention. So in that case, you have to apply this equation. So this is a basic equation you have to remember for solving numericals on work and heat. If any condition is given in the numerical, pressure is constant, volume is constant, or temperature is constant, then in that case we cannot use this equation. Okay, for example, in the numerical isochoric is given. Let us assume that he has given isochoric. What is the meaning of isochoric? Volume is constant. So what is the expression for work done for isochoric is 0. So do not apply any formula, do not scratch your head in writing the equation for isochoric. If the volume is constant, directly you write work done is 0. Okay. Second process, isobaric process. Isobaric or isobaric process. I given hint in the previous video lecture how to remember which property is constant. Here bar is a unit of pressure, so pressure is equal to constant. Just you remember like that. Bar is a unit of pressure, so pressure is constant. Now we need to remember the expression for work done for constant pressure. So work done between 1 to 2 process. In general, I am writing 1 to 2. If you are calculating for 3 to 4, you have to write 3 to 4. 5 to 6, you have to write 5 to 6. It means initial point to final point. This is equal to pressure into final volume minus initial volume. Okay, now this is not the right time to explain you how you got this equation. Now because this is exam period of time, you have to by heart equation, and I will give some hint how to solve the numericals also. Pressure into final volume minus initial volume. So pressure is, I have not taken initial pressure or final pressure because entire process the pressure is constant. I will give an example. Let us assume that the process is going from point number 1 to point number 2. This is point number 2. This is point number 1. This is initial and this is final point. This is final. So volume at initial point he will be given in the numerical. 100% he will give volume. V1 is equal to 0.1. and V2 will be given in the numerical. V2 is equal to 0.6. Let us assume simple. And during 1 to 2 process, the pressure is constant. Constant pressure, it may be 2 bar or 3 bar, 4 bar, whatever may be. So when the pressure is constant throughout the process, P1 also equal to 2 bar, P2 is also equal to 2 bar because constant pressure. So for this process, how to apply this equation? So W 1 to 2. Why I am writing 1 to 2? Because I have taken initial point is 1, final point is 2. In some numericals, for confusing the students, he will change initial point as A, final point as B. In this case, do not take 1 and 2 because he has clearly has given A and B. So I need to write A to B process. Work done during A to B is equal to, what is the pressure in this throughout the process? It is 2 bar and it is constant. Each and every point the pressure is constant, so substitute as 2. How much is the final volume? 0.6. 0.6 minus initial volume is 0.1. So this is how we have to calculate work done for isobaric process. Similarly, I will write an expression for isothermal isothermal process. Again, which property remains constant here in the isothermal? Only you have to search between these three. Pressure is over, volume is over. So only left is temperature. Here T stands for temperature. Here we will not get any T. Here is also there is no letter T in this isobaric, isochoric. But here we are getting T is a temperature. So temperature remains constant. Constant temperature. So what is the expression for constant temperature is? Remember this equation now again. 1 to 2 P1 V1 ln of V2 by V1. Again, dear students, do not get confused with 1, 1, 2 and 1. So remember in general, initial pressure, initial volume, ln of final volume divided by initial volume. Because in exam 40 to 50% of the students will do the mistake in substituting the values. For example, I am asking to calculate work done for 3 to 4. I have given V3 and I have given V4, but students will apply V2 and V1. They have taken and they have backdated the things. Always they will write V2. Do not write V2. V2 is nothing but final volume. Anybody could you tell me the expression for this process? Expression for work done for this process using this equation. Using this equation, please tell me anybody.
W324 equals P
Yes,
P3
W3 to
V3
4 is equal to
P3 V3 ln
ln
V4 minus ln
V4.
V4 divided by V3.
Yes, this is how you need to write. Okay. So first, when you are writing an expression for isothermal, first you identify which is initial, which is final. Okay. And you substitute here. Okay. Now, dear students, sometimes instead of giving V4 and V3, he will give P4 and P3. P3 will be given here and P4 will be given. But he will not give V4. V4 is unknown. He has not given in the statement in the given data. Instead of V4, P4 is given. Then how to write an expression for work done? And we cannot say it is insufficient data, we should not come outside. Is there any way to convert volume in terms of pressure? Okay, remember this equation, what I am saying, listen carefully. V4 is not given, or else in simple way I will tell any one volume will be given. Either V3 will be given, that is initial volume will be given, or else final volume will be given, any one. Okay, instead of two volumes, only one volume will be given and two pressures will be given. So in this case, I have taken one pressure and two volumes. And he may change. He will give two pressure, only one volume. In that case, how to solve this numerical? Okay. Next step, you remember this equation. This equation you can apply for any processes, not only this process. Dear students, I hope you remember the expression or simple equation for ideal gas. What is the expression for ideal gas? PV is equal to MRT. PV is equal to MRT. This is the ideal gas equation. And here, for the given process, always we will assume M is equal to 1 kg. Assume in this process it is carbon dioxide. There is only one gas and its mass is equal to 1. So it is constant value. And R value is also constant. This is gas constant of carbon dioxide is also some constant value. It is not zero. It has some value. It may be 20, 30, 40, whatever may be. It has some value. It is constant. And in this process, isothermal, which property is constant? Temperature is constant. Here T is also constant. So constant, I am not saying zero. Okay. This may be 10, this may be 20 value, and this may be 1 kg. 1 into 20 into 10, you will get some value, 200. That is constant value. It has some value, it is not zero. So P1, I will apply this equation for this process, initial point. So P3, V3 is equal to some constant value. Same expression you write in the final point here. How will you write? P4, V4 is equal to constant. Constant means it has same value. Here it is also 200. Here is also 200. Right hand side is same on both the side. So obviously left hand side should be equal. So P3, V3 is equal to P4, V4. I need volume ratio. I don't want V4 by V3. I need in terms of pressure. So same expression, I will convert V4 by V3. This you take in the right hand side of the denominator. This you take on the left hand side of the denominator. So it will become P3 by P4. So in place of this equation, you can also write W324 is equal to P3 V3 ln of P3 by P4. This is also equation. Okay. For same process, you have to identify the data, which data is given, then you choose the equation. Now, what is a hint? How to remember these two equations? Hint is, look at the equation here. Always initial condition will be given. Just to remember, initial condition will be given 100%. Okay, most of the cases initial condition will be given. Here if you write P1 V1 ln of, you take V2 final here, final volume, initial volume. But when you are taking pressure, whatever the pressure is there here, you take the same pressure in the numerator. Okay, that is what I can give you the hint. P3 P3 here. Whatever the pressure you will take here, same pressure you have to take here. But if you are writing for volume, what pressure volume is not given here, you have to take here. Reciprocal. That is a simple word, remember. Okay. So this is the third process. Fourth process is, okay, if you understand these four processes, you can solve any numerical. So do not by heart any equation, try to understand. The fourth process is adiabatic, or it is not same, but I am writing the expression for adiabatic and polytropic at a time. Okay. So what is the expression for these two processes? Again, initial to final 1 to 2 is equal to P1 V1 minus P2 V2 divided by gamma minus 1. If it is gamma value, this is for adiabatic process. If it is n value, P1 V1 minus P2 V2 divided by, if you take n value, if you write n, then it is for polytropic process. This is for adiabatic process. Then you can ask, what is the difference, sir? If gamma is value may be given, may not be given. So always remember gamma value is 1.4. n value is more than 1.4. Okay, and this n value will be given in the numerical. It may be 2, it may be 3, it may be 4. And dear students, sometimes n value will not be given. Okay, he'll say that clearly he'll use the word polytropic, but n value will not be given. In that case, how to calculate n value? You cannot assume it is 1.4. If it is gamma, you can assume it is 1.4. What is gamma? It is adiabatic index. Adiabatic index. Why it is adiabatic index? Because gamma is related to adiabatic process. So it is adiabatic index. What is n? N is related to polytropic. So it is polytropic index. So how to calculate this n value is again one simple equation. Remember this equation, simple. So any process which follow the law P1 V1 to the power of n is equal to P2 V2 to the power of n. Both similarly what we have written here, same expression like this. Here gamma will not come into the picture. In this equation, gamma will not come into the picture, but here in the denominator adiabatic, only gamma will come. So these four conditions will be given. P1 will be given, P2 will be given, V1 will be given, V2 will be given. So substitute all four values and calculate n. So this n value you substitute here and calculate expression for work done. Or else n value will be given directly, n value will be given, P1 will be given, P2 will be given, V1 will be given, but V2 will not given. Again, what is the procedure to calculate V2? Again, you have to use this equation. P1 will be given, V1 will be given, P2 will be given, V2 will not be given, but n will be given. So substitute here in this equation and calculate n value. That n you substitute and all values. Okay. Now I will give one equation. You have to tell me expression for work done. Okay. Listen carefully my words. Carefully. The thermodynamic process followed by polytropic process, polytropic equation, polytropic process. The process is going from A to B. Now, first you tell me for A to B process, what is the expression for work done? Assume it is polytropic. Assume it is polytropic. How will you tell the equation?
WA to B equals PAVA,
WA to B equals
PAVA minus
PAVA. So instead of using the word PAVA, make it a using of initial pressure, initial volume like that. Initial pressure. Next,
initial volume
initial volume.
minus
Okay. Next,
PB minus PB
okay,
into PB
divided by
divided by N minus
what
1.
is N?
We find,
What is N?
sir, a poly index,
Polytropic index.
index,
Polytropic.
polytropic.
Okay,
Yes.
polytropic index. Okay. Okay, my dear students, one more condition. The process is going from like this. Okay. Tell me. For this process, assume, okay, let me change little bit I will change so that you will understand better. Okay, the process is like that. This is D, this is C. Okay, assume this is a polytropic process. Now you tell me. You have to identify which one is initial point. Now, out of these, for this process, which one is initial point?
D.
D is initial or C is initial?
D.
D. Okay. Which one is final?
C. C.
Yeah. Now, okay, use this equation and tell me expression for work.
WD to C equals
Yes, WD to C equals
PDVD minus PCVC divided by polytropic index.
minus 1. Okay. He has not given polytropic index here. So which equation will you apply for this
Sir,
process?
PDVD
Yes. PdVd
PDVD to the power of n equals PCVC to the power of n.
n. Very good. Okay, this is how we need to remember these four equations. This is one equation. This is second equation. Okay, and third equation is for isothermal. This is a third equation for isothermal, and fourth equation is isobaric. And anyway, value of work done is 0 for constant volume process. Okay, so no need to buy it. Whenever you say constant volume process, then for that process work done is 0. Okay, we'll take one numerical. Okay, we'll consider one numerical. First point, what we need to do in solving the numericals is identify the process. Out of 5, which process is given? Whether it is single process or combination of 2 process or 3 process, whichever may be, do not worry. First identify the process. Once you identify, write the given data, what he has given, what he has not given. Then write the formula. Third point is write the formula. Okay, and calculate the unknowns. These are the steps. Okay, what are the steps we'll do? First step, remember my dear, and it is not standard, my dear students. Don't think that it is standards, always you have to follow the same. No. First step, write down the given data, because in the sometimes you will get 1 or 2 marks for the given data in the rare case. Second point, identify the process, whether it is isochoric, whether it is isobaric, whether it is isothermal or polytropic or adiabatic index. Identify out of these 5 which process is given in the numerical. Next, third process, write down the work done expression for the given process. Expression for work done for the given process. And dear students, do not think that only one process will be given always. No, he may give 2 processes continuously. For example, constant pressure, adiabatic, constant pressure, again constant volume, like this. It may be cyclic process. Do not think, oh, only one process will be given, it will become easy for solving numeric. No, not like that. Okay. For example, you are coming from home to college. That is one process. Now, after the classes, again you are going back from college to home. So how many processes are there here?
Two process.
Two processes. Two process. Calculate the work done for first process. Calculate the work done for second process. Add these two over. Simple. Okay. Expression for work done. Now, fourth point, what we need to remember here is one more point. Sometimes what he will give value of work done. Work done value will be given directly. And he may ask you to calculate pressure, volume, temperature, etc. Okay. 70 to 80% of the numericals, he may ask to calculate work done. He will give pressure, volume, and temperatures, adiabatic index, polytropic index, etc. All values will be given. And he may ask to calculate work done. But sometimes in 20% of the numericals, what they do, he will give the work done and he may ask you to calculate the pressure, reverse. You have to do the reverse process here. So you need to remember one more point, simple point is, if the work is done on the system, it is important. Work is done on the system, you take it as positive value. Sorry, it is negative value. This heat supplied, this is for negative value. Work is done on the system, you take negative value. Work is done by the system, you take it is positive value. I will give an example. For example, the turbine is undergoing a polytropic process. During the process, the turbine is producing or developing 30 joule of energy. Turbine is producing or developing 30 joule of energy, means the system is turbine. This turbine is producing or developing 30 joule of energy. So will you take minus or plus for this 30 joule?
Plus one. Producing.
Plus value, because turbine is giving work is done by the turbine. Okay, work is done. If it is work is done on the system, then it is negative. I will give one more example. Okay, to run the fan, I have to supply 40 joule of energy, electrical energy. So fan is a system here. So with respect to 40 joule and with respect to the direction of work, I am supplying 40 joule of energy. So fan is a system. I am supplying 40 joule of energy. So negative value or positive value?
Negative, sir.
Negative, minus 40 joule. Okay, understood? Nodi, simple agide alli. I am giving 100 rupees to you andre same meaning ಏನು, you are taking 100 rupees from me. Both are same. For confusing the students, he may change words. He may change the words, but concept is same. You are taking 100 rupees from me. Okay, that is the same as I am giving 100 rupees to you. Both are same. Fan is absorbing 40 joule of energy is same as 40 joule of energy is supplied to the fan. Both are same. Both are same. Do not get confused. Okay, so we will solve one numerical now. Okay, I hope you understand all these processes. These process values you have to apply to solve this simple numerical. It is very simple numerical. I don't know whether it is one process or two process, three process, or it is maybe combination of more than two. First process, first step, what we need to do? What is the first step? What we need to do? Solution, given data. Yes, first given data. Okay, read the statement. A piston cylinder device initially contains 0.4 meter cube. Initially contains 0.4 meter cube, and he has not used the word pressure, volume or temperature. He will not use also. So based on the unit, you have to decide which property it is. Which property is given now?
Volume.
Volume. Okay, so what should write here given the given data?
V1.
V1. Very good. So this is piston, this is cylinder. Just I'm a simple sketch. It is not necessary to draw the sketch always, but please make a habit of drawing such sketches. So numericals will become easy. So cylinder and the piston, and here it contains some gases. Some gases are there. Not gas. He has given air. Okay, air is the one. Let us assume that it is air. What is the volume of the air? He has given V1 is equal to 0.4 meter cube. At 100 kilopascal. Kilopascal. Pascal is the unit of? Pascal is a unit of volume, temperature or pressure?
Pressure.
Pressure. So pressure is given. So P1. Okay, 100 kilopascal. And dear students, please make a habit of converting kilo to normal. Try to remove this kilo. So what we have to do is 100. To remove this kilo, we have to multiply with 10 to the power of 3. So Pascal is nothing but Newton per meter square. Both are same. Pascal or Newton per meter square, both are same. 1 Pascal is equal to 1 Newton per meter square. So why I'm writing in terms of Newton per meter square is, here is also in meter. It should be in terms of meter. All units should be homogeneous. Sometimes in the given numerical, he will use centimeter cube. This will be in centimeter. This will be in meter. So you have to convert this centimeter into meter. Okay. For confusing the students, some professors, they do such values. Okay. And 80 degrees Celsius. 80 degrees Celsius means Which value?
Temperature.
Temperature.
T1 is equal to 80 degree Celsius. Next point. Read the next line. The air is now compressed. Important word. Compressed. This air is compressed. System is air. This is a system. Air is a system now. So this air is compressed. Compressed means once you compress, volume of the air increases or decreases?
Decreases.
Decreases, because this piston we have to move upward so that air get compressed. So after compression, the volume he has given as 0.1 meter cube. So I will write V2 is equal to 0.1. I will use the same color so it not become confused. Okay, so V2 is equal to 0.1 meter cube. So here there is a decrease in the volume. Initially 0.4, it is decreases to 0.1. If it is expansion, volume increases or decreases? Assume in place of compressed, expands. Air expands. Then volume will be more than 0.4 or less than 0.4?
More than.
More than 0.4. Correct.
More than.
Yes. Note next line. So in such a way that how the compression is going, compression process is undergoing in such a way that the temperature inside the cylinder remains constant. Temperature is not changing during this compression process. So how much will be that final temperature? Temperature remains constant. Initial temperature is 80 degrees Celsius and you are compressing the air, and after compression during the compression temperature is constant. So how much will be the final temperature?
80.
80. Very good. Okay, 80 degrees Celsius. So here is also 80, here is also 80. So determine work done during the process. So he is asking work done during the process. Let me take, he has not given A to B, 1 to 2, 3 to 4, not like that. So always I will choose 1 to 2, how much? Okay, you have written given data. First step you have done, right? Very good. Given data is over. What is the second step? You have to identify the process. Out of 6 processes or 4 processes or 5 process, which process it is?
Isothermal, sir.
Isothermal. Why you are saying it is isothermal?
Sir, because temperature remains constant.
Yeah, here 80 degrees Celsius initial and final temperature is also same. So it is constant temperature. Very good. I will write here it is the given process is isothermal. Isothermal process. So what is the next step will you do? You have to write expression for isothermal. What is the expression for isothermal? Expression of work done for isothermal?
100 into
No. First you tell me the formula.
P1
P1 V1 ln V2 minus V1.
Ln of
V2 minus V1.
V2.
Divided by V2 divided by
V2 minus V1.
divided by, sir, divided
V2
by
by V1.
V2 by V1. Why you have taken this equation? Why you have not taken in terms of pressure? Can I take this equation?
no
Is it both are
No.
same or different equation?
different.
Why you are not chosen this equation? Why you have selected
sir,
this?
sir, in given data
Pressure.
they already given
Yes,
V1
both
and
V1
V2,
and
sir.
V2 is given, so we have choose this equation. If V2 is not given, P2 is given, then you have to use this equation. Okay, so time being I will not use this equation. Okay, but you will get the same answer. Okay, if you use this equation or if you use this equation, you should get the same answers. Okay, now we'll substitute the values. How much is the value of P1?
100 into
100 into 10 to the power of
10 to
3.
the power of 3 into
Into
0.4.
10 to the power of 3. V1 is 0.
0.4.
Ln of
0.1 divided by 0.4.
0.1 by 0.4.
0.1 divided by 0.0. Okay, dear students, before calculating this answer, You tell me, will you get value of work done is negative or positive?
Negative.
Why it is negative?
Negative, sir. Sir, because
Why it is negative?
sir, V2 is compressed 0.1, sir.
Yes, the process is compression. Compression is you have to
Negative.
supply work to the air. Work is done on the system. Work done on the system should be negative value. So if you have anybody have calculator, simplify
Sir,
this equation.
minus 55,451 kilojoule.
55,000 kilojoule. This is a value. So you have to get minus. Okay. Okay, dear students, what I do is I will remove this V2. Let us assume that V2 is not given. Okay. How will you calculate V2?
Second equation, sir. P1 V1 ln P2 by P1.
No, P2 is also not given. Is there any solution? P2 is also not given. Let us assume that V2 will also not given. How will you calculate V2?
Sir, by taking temperature.
Taking temperature, you tell me how? Because I need V2. Compulsory, I need V2. Or else I need P2. Anyone I should, must and should I require to solve value of work done. What I am saying is V2 is not given. Assume P2 is also not given. How to calculate V2 or how will you calculate P2? Using these data. This data is given. We have not used this data either in this equation or in this equation because volume is given directly. If volume is not given, how will you apply the equation? Which equation will you consider?
General equation.
General equation for which process? I will go to the previous page. I will go to the previous page slowly. Is there any equation related to isothermal? Look at this equation. Somewhere I have given, I have explained you. You have
Is equal PV is equal to MRT.
yes, you have to use this equation, my dear students. You have to use this equation. Okay. So let me write. Okay, let me write here. So PV, this is a second method to solve the same numerical. PV is equal to MRT. Okay, P1. First I will write at the initial point. P1, V1, M1, R1, T1. Okay, I will write in the final P2, V2 is equal to M2, R2, T2. Value of M, R and T is constant. T is also 80 degree. M is 1. R is also constant for the air. So this value will be constant and you will get some value, some X value. It is not 0, it is X value. And here is also same value will get. Same value. It is also equal to X. Same value will get because M is will consider same. R is also will consider same. T2 is 80 degree. So we will get the X value. So P1 V1 is equal to P2 value will get. Okay. So using these equation, I am asking you to calculate V2. Okay. V2 is equal to P1 V1 divided by P2. But I am saying P2 is also not known. P2 is also not given. How to calculate P2? If you know the P2, you can calculate V2 using this equation. There is no doubt about it. But I don't know P2 also. Is there any equation on the screen to calculate P2? Use this equation. This equation separately.
Same
Use
equation.
only this equation. Yes. P2 V2 is equal to M2 R2 T2. Temperature is given. Okay. Mass is you take 1 kg. Gas constant is also you take constant sum. And V2 is given in the numerical. Okay. Or else But this is a rare case, my dear students. Do not get confused. This is a rare case. If the problem is given like this, you have to calculate using this equation and this equation, calculate the unknowns and substitute. Rare case. Otherwise, directly some values will be given. Any doubts in this numerical?
No, sir.
Any doubts in
No,
this
sir.
numerical?
No, sir.
Okay.
No, sir.
How many processes are there here in the given numerical? How many processes are there in this numerical?
Two process.
Only one process or two process?
One process.
Only one process.
Only
Okay. Yes. Okay. We will go to the next. Use this equation now. Okay. Read the statement. To a closed system, 150 kilojoule of work is done on it. On it means what? Let us assume this is a system. System nothing but any device. Okay. It may be fan, turbine, compressor, human body, laptop, whatever may be. It means a device. It means machine. Okay. Just assume it is a machine or one device. So 150 kilojoule of work is done on it. On it means arrow mark should be towards like this 150. So step number 1, I am writing the given data. Okay. Now you tell me what should I write here?
minus 150, sir.
Minus 150. Shall I write directly? Okay, okay. Minus 150. Which value it is?
Work done. W.
Work done. Yeah, you have to write currently. Work done during 1 to 2 process. It is 150 kilojoule. What is the next step you will do? Here you are seeing kilo. What you need to do? Kilo convert to joule.
Joule.
Kilojoule multiply by 10 power of 3. Okay, next line. Next, continue. If the initial volume is 0.6 meter cube, which value is given?
V1.
V1, 0.6 meter cube. And pressure of the system varies as follows. He has not given directly the pressure, but pressure depends on the volume like this. This is the equation he has given. We don't know whether volume increases, pressure increases or not. We don't know whether volume decreasing, pressure decreases. It is a relation he has given. Okay. As the volume changes, pressure also changes. Either it may be increase or it may be decrease. So this equation he has given. Let me write the same equation once again clearly. 8 minus 4V. Okay. Next line. Where P is a pressure in bar. This is very, very important. Such type of numericals are very important because here he has given pressure is bar. So this value, this equation is in bar. Yes, it is in bar. So once you substitute the value of V, you will get the pressure in bar. So you have to write 8 minus 4V into 10 to the power of 5 Newton per meter square, because it is in bar. Next, and V is a volume in meter cube. Yes, this volume he has given in meter cube. Determine the final volume and pressure of the system. Final volume means which? V1 or V2?
V2, sir.
V2.
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 Final pressure?
V2.
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 And final.
Now this is the reverse of, as I told you in the just before 10 minutes, work done will be given. And he may ask you to calculate final pressure or initial pressure or final volume and initial volume. Okay. But here work done is given. Work done is given as 150. Initial volume is also given. And he is asking to calculate V2 and P2. So how will you do it? You have written the given data. What is the next process? What is the next step we'll do? Identify the process.
Equation, sir.
Identify the process. Is there any process he has given clearly like that isobaric, isochoric,
No, sir.
constant temperature? Okay, he has not mentioned any process. Not mentioned. It is not given. Not necessary write in the exam. Okay, do not write such things in the exam. Just only for understanding. He has not mentioned any thermodynamic process. So what we need to do when he has not mentioned, which is the general expression for work done?
PdV.
Yes, here we have written, no? Somewhere you have written here. On this page, yes, I have written here. If any pressure is not mentioned in the given numerical or any thermodynamic process is not mentioned, then you choose this equation, general expression. Using this equation only we have derived this for constant volume, constant pressure, isothermal, etc. This is a basic equation. So general expression, we will call it as general expression for work done, that I will write here. Expression for work done during 1 to 2 process, integral of 1 to 2 PdV. But P is not given directly, volume is also not given. So but equation is given. This equation I will substitute initial to final. And dear students, again I am telling you, this is not all standard. Either you take A to B, C to D, X to Y, P Q Z, A another, no issues. But standard is 1 to 2. It is writing. P, what is the expression for P? 8 minus 4V into 10 to the power of 5. Do not forget this 10 to the power of 5. Okay, because we have converted into Pascal. So what is the value of work done he has given? Minus. Minus he has given. On the left hand side, I will substitute 150 into 10 to the power of 3 is equal to, let me write the same equation, 8 minus 4V into 10 to the power of 5, that I will take outside. Anyway, it is constant, into dV. dV as it is. Here is a dV, write as it is. So 10 to the power of 3 and 10 to the power of 5, 10 to the power of 3 get cancelled. So it remains is 150. Here 10 to the power of 2 will remain. That I can take in the denominator, right? With your permission. Shall I take like that? Here, whatever there, I will
Yes,
take
sir.
this on the right hand side. Okay. So integral of 1 to 2, 8 dV minus integral of 1 to 2, 4 dV. If you are perfect in mathematics, you can do directly. No need to write the split up of this. No need to write split up. Here there are two terms, so I have written the integration separately. Again here it is 100. 100, 10 get cancelled, so minus 1.5. 15 divided by 10 is 1.5 along with minus. So what is the integration of 8 dV? What is the
8
integration
feet.
of x dx? 2x dx. 2 is constant, x is variable. Here 8 is constant, take outside. What is the integration of x dx? Or you remember like this, what is the integration of this? Integration of dx, x. Okay, right, x between the limits 1 to 2 minus 4 is constant, take out. What is the integration of v dv? V nothing but x dx. V is x, dv is dx. What is the integration of x dx?
ಆಯ್ತಲ್ಲ
Integration of
ಆಶ್ಚರ್ಯ ಯಾಕೋ ಇವಾಗ ನಿನ್ನೆ
x is x square by 2. Please mute yourself. Please mute yourself. Do not disturb the classes. So 4 v square by 2 between the limits 1 to 2. Okay, I will write the formula here. Integration of x dx is x to the power of n plus 1 divided by n plus 1. Till power is 1. So x to the power of 1 plus 1 is right legs. Again n is 1 plus 1. So x square divided by 2. So here is x is there. So x square. If it is v square by 2. That I have written here. Okay, now Substitute the limits, minus 1.5. And dear students, what are the limits will you take here? Whether P1 to P2 or V1 to V2? Which limits will take? Shall I take P1 to P2? Shall I take right like this, P1 to P2? Well, this is right, or writing this one is right, V1 to V2?
V1 to V2.
Why V1 to V2 is right? Why not P1 to P2? ಮೇಡಮ್ ಸಾಲ್ವ್ ಮಾಡಿದ್ದಾರೆ ಕ್ಲಾಸಲ್ಲಿ, ಮೇಡಮ್ ಸಾಲ್ವ್ ಮಾಡಿದ್ದಾರೆ, ಅದಕ್ಕೆ ಹಿಂಗೆ ಬಂದಿದೆ. ಓಕೆ, here look at this value dV. This is change in volume. Here change in volume, so we have to write the limits in terms of volume. If the given condition it is like this 8 dP, if it is like this, then you have to take P1 to P2 because change in pressure you need. So here V1 and here V2. So here X is not there, it is V. Okay, it is not X, because V is there. Okay, next. Substitute the limits. 8 into upper limit is V2 minus V1. Okay, one more hint, one more point I need to tell here, my dear students. Majority of the students in the exam, what they do is, they will write like this. They will apply the mathematics rule, dip maths. Inga baritare. Sir, the limits, it is not a value, it is a limit. V2 you have to write. In mathematics, you will write 2 minus T1 like that. This is wrong. You have to write the limits along with property. ಕೆಲವೊಬ್ಬರು ಹಂಗೆ ಬರೀತಾರಲ್ಲ, 8 ಬರೆದು 2 minus 1, 4 by 2, 2 minus 1, 2 minus 1, 1 1 ಮಾಡಿಬಿಟ್ಟು ಆನ್ಸರ್ ಹೊಗೆ ಹಾಕ್ಸ್ಕೊಂಡು ಹೋಗುತ್ತೆ. This is wrong. So minus, always write upper limit first, lower limit next. So 4 by 2, it cancel, you will remain 2. Now tell me what should write here? What should I write here? V square.
V2 square.
Okay. So
V2 square.
oh, correct. Yes, correct. So substitute all the values. Minus 1.5 you write, 8, V2 minus V1. I think V1 is given. How much he has given in the numerical? V1 value is 0.6. That is what he has given here, 0.6. So write down that value. V1 is 0.6 directly. Minus 2. V2 square we don't know. V1 is 0.6 whole square. So use the calculator and simplify this equation. 8V2 minus 8 into 0.6 minus 2V2 square minus into minus plus 2 into 0.6 whole square. So only unknown is V2. Calculate V2. We'll get some value. Okay. My question is, the value of V2 should be more than V1 or less than V1. V1 value is 0.c as given. This value of V2 should be more than V1 after calculating, or it should be less than V1.
Less than V.
Why it is less? Why it is less? I will say more. It should be more than. Why it is less?
More than.
Okay, there will be only two answers, either more or less. You have to give the answer, reason for it. Answer is right. Value of V2 final volume should be less than this value. Why?
Because work done is minus.
Work done is on the system. This air is there. Initial volume of the air is 0.6 meter cube. And external work is done on the system, means compression process. You are compressing the balloon. The balloon volume is 0.6. You hold the balloon of the air. Okay, volume of air, you can take balloon or air, whatever. The volume of the balloon is 0.6 and you are pressing the balloon. Once you press the balloon, what will happen? The size, the volume of the balloon decreases. So V2 should be less than 0.6. Due to some calculator mistake, if you got it should be more than 0.6, assume you have done wrong. Something is wrong. And after repeated calculation, you are doing same thing. You should write less than 0.6 something value. That is concept of thermodynamics. You should get less than, and it's not minus also. It is less than 0.6. Okay, you calculate this value in the calculator and substitute in this equation. This is the one value. Next, what he has asked, one more data he has asked, no? Volume you have calculated. How will you calculate pressure, final pressure? Volume you have calculated. This volume you will get less than 0.6. Okay, fine. That how will you calculate P2? Is there any equation you are seeing on the screen where you can calculate pressure out?
Sir, by equation.
Yes, using by this equation. Using by this equation. So this equation what he has given? Let me write. So P is equal to 8 minus 4V into 10 to the power of 5. And I need P2. P2 is equal to 8 minus 4. V2 we have to substitute here. You take V2 into 10 to the power of 5. Once you substitute the value, P2 will get some value. Okay, assume P1 is 1 bar. Assume P1 is 1 bar. How much value of P2? P2 should be more than 1 bar or less than 1 bar? More than 1 bar, because
More.
when you compress any fluid, the pressure of the fluid increases, volume decreases. So you should get more than 1 bar. This is the right. Okay, this is answer. Any doubts? Maybe some students they have practiced in the class. Okay, in the madam class. Any doubts for these two numericals? Yes.
No, sir.
Yes. Any doubts?
No.
Aeronautical students. Yes. Yes. Are you there? Yes. Mano. Okay.
Yes, sir.
Okay. Fine. Very good. Okay. Okay. Next, last numerical, and we will in the evening. I will take the different topics. I will take on first law of thermodynamics. Okay. Read the statement. First step. It is complicated. It is a little bit tough. So what we do is we will take on 5 minutes break and we will start. Okay. I will take on 5 minutes break.
Okay, sir.
Okay. You can leave the meeting and using the same link you can join once again. Only 5 minutes. Here time is 11:22. I will come back to exactly at 11:27 or 11:30. Okay. Bye.